All right, problem of the day. This should look familiar. So just read it over. We're not going to solve it. We're just going to set it up. So the base of a pyramid-shaped tank is square to bottom. The sides are 12 feet, and the vertex of the pyramid is 10 feet above the ground. The tank is filled to a depth of 4 feet. Water is flowing into the tank at the rate of 2 cubic feet per minute. Find the rate of change of the depth of the water. And then they give you the hint, the pyramid's volume is 1/3 base times height. Just kind of sketch a picture and get it organized. And I'm going to take attendance and then we'll talk about it. Last Friday, when you got your notebook, was Julia Johnson's notebook tucked inside yours? Or loose leaf? What did it call? No one? When you look, check your points. Yours was tucked in there by accident, huh? Well, that's a mystery then, right? Okay, let's talk about this. It's a pyramid that's square along the bottom. It's 12 feet by 12 feet and has a height of 10 feet. What do you know about the volume? And then it's filled with water. And how deep is the water? 4 feet. And what's happening? Is the water rising? So that means dV dt is equal to 2. All right. These are dull. I think I gave you a hint on this one. Remember the hint? Because you're trying to figure out the rate of the rising water. Well, it'd be pretty hard to figure out this h. So instead, figure out this h. Because the air is decreasing at the same rate at which the water is rising. So then, instead of figuring out the volume of this pyramid, or this quadrilateral shape, a trapezoid, you can figure out the volume of the triangular shape. So what's the volume of a triangular shape? It's 1/3 big base times height. Well, there's the h we're looking for. Let's just take the derivative of both sides and we're done, except for what? Got two variables here. So we've got to go back and get rid of that variable. Let's call the length of this triangular shape b, and that would be d. Now, what is the relationship between b and h? Because we know that this triangle is similar to that triangle. So that means what? 10 over 12 is always going to be the same ratio as h is to b. So that means that h is 5/6 of B, or B is 12/10 H, 6/5 of H, whichever is usable. We okay in that? That's the key thing, is to realize that there's a similarity between that and the big one. Of course, the other key thing is to make use of this triangle instead of using the trapezoid, because that's pretty messy. So now, the volume is 1/3 the base. Well, the base is the length of the side squared times height. But what is B? It is 6/5 of H. So replace it with 6/5 of H. And now we have a volume formula with only one variable H. So your volume would then be 1/3 times 36 over 25 H squared H, which is 36 over 75 H cubed. And what are we looking for? We're looking how fast the water is rising, so we're looking how fast dH dt is moving. So how do you do that? Take the derivative of both sides with respect to time. So dV dt is equal to 3 times 36 over 75 times H squared times dH dt. Okay, any questions? Now that was on the chapter 4 test. I think we had different numbers for your test, but it's the same question. Then you plug in H. What do we plug in for H? 4? We plug in 6, because we're talking about the pyramid. And then we plug in dV dt is 2, and then you can solve for dH. The height is 10.
Oh, yeah.
And we're using the pyramid as opposed to using the quadrilateral shape, trapezoid shape. All right? Okay.
Did you actually?
I had a chance years ago to visit a lot of college calculus courses, and I talked to the professors. And you know what they said the biggest problem was? Students' algebra skills. Some of them, man, it's awful. No, you don't have to leave it. We're not going to discuss it right
I think it's about 30. It is.
So bad you don't want to give it back. Right there. You might be absent. Why? Oh God.
This is a circle. These are also
Isn't that a beautiful transition?
Because I got so many different. Grace. Oh. I got 8. Okay. All right. Since a number of you haven't taken it, we're not going to discuss it as a class, but individually I'll go over it with you. But I would like to make a couple comments. If it does not say solve analytically, and you're given an integral, do you have to do it by hand? No, you can plug it in your calculator, and in 2 seconds have the answer. Okay? You should know how to do it analytically, but if it doesn't say that, you don't have to. Okay, the next thing is the algebraic scariness. Do not embarrass me and go to college next year and square this and say it's 16 over x squared minus 1 or plus 1. Oh, all right? I bet you there was 5 or 6 of you that did something like that. So be careful. It's easy in a test, you just, you're kind of blank out. But don't just square a binomial like that. Okay, I think that's all I'm going to say now. Individually, if there's questions, I'll look at them. There are a couple on there that I'll do as a whole class once everyone's taken it, and I want to emphasize a couple things. You're still pretty weak on the tin can method, so we got to make sure that you know how to at least do it. Okay. Okay, the topic in the 7.4 length of a curve. When we started integrals, we were finding area under a curve. It was easy to find the area under this curve because it was length times height, and we were done. It wasn't so easy under this because the curve didn't have a set formula, so what did we do? We sliced it into rectangles and added up all the rectangles, and we got an approximate area. And then we got an exact area by doing what with the rectangles? Making them real small, real thin, which means we are basically adding an infinite number of rectangles. We're going to do the same concept for finding the length of a curve. Here's a curve that goes from A to B. How long is the curve? Well, it's pretty hard because all of our rulers for measuring distances are straight. And so we can't really measure the curve because it's going to continuously... So, what we do is the same thing we did there. Let's just measure part of the curve. Let's just go from here to here and find this length. Now, is it exactly the length of the curve from there to there? No, but it's pretty close because we've made it short enough distance. We didn't go from this point to that point and had a huge error. We went a short distance. In fact, you can go only a tiny distance when we're going to actually do it. So, let's find that distance. Well, that's pretty easy because we've gone over a distance, delta x. We've gone up a distance, delta y. To find d, you simply use Pythagorean's theorem. So Pythagorean's theorem says a squared plus b squared equals c squared. So d is the square root of delta x squared plus delta y squared. And we've got this distance. Now if we do the same thing for here, and there, and there, and there, and there, add them up, we've got the length of the curve. Well, to do that, we have to integrate if we make them a bunch of small ones. If we just make 10 of them, we can just add them up. We don't have to integrate, but if we're going to do an infinite number, we need to integrate. So we need to convert this into something that we can integrate. So let's factor out a delta x squared from this inside portion. If I factor it out, I get 1 plus delta y over delta x squared. Because if I was to remultiply it back, it would give me with the delta y squared. Okay. Now let's just pull that out of the square root. If you pull that out, it becomes a delta x squared brought out. Delta x. So I'm going to put it on the back side over here. And you guys okay?
Really excited.
That's what we want to hear. All right. Delta x, delta y is the actual distance, but for small values, we can call this dx, and we can call that dy, the change in the function. So this becomes 1 plus dy dx squared, and then this becomes dx.
Do we need to know how to do this retroactively?
No, but it's good to see it happening.
Why?
You're going to see a lot of college professors that are going to go through everything, and you need to be used to that. None of this will be on the AP test, which is right. But I really feel that you need to see it happening. And besides, you are not the people that are going to be given a formula at a company and say, find the answer. You're going to be the people that come up with the formula that they're going to be using, the algorithm that's going to be using to solve the problems. And so you know, you need to see how that comes. You're not gonna be the ones that integrate it, you're gonna be the ones that are gonna develop the algorithms for whatever company or things that you work for. Yes?
Why isn't change in x squared when you move it? Or it's
Oh, you pulled it out
I
of.
pulled it out of the square root,
Oh,
and it then becomes delta. Okay, so now, what have we just found? We found the length of this. Now we want to add all of them, so what do? Integrate from A to B. So the distance of a curve, the length of a curve, is simply the integral from A to B, the square root of 1 plus, Sam, I can hear you. Talk so I can't hear you. What is dy dx? That is the derivative of the function. So we take the derivative of the function, and what do we do to it? We square it. And that's what you integrate. And there's the formula. That's all there is to it.
yeah, formula we read in the homework. We came up with the formula. We are an hour.
All right. So, example. Find the length of a curve from 0 to 1 for y equals 4 times the square root of 2 over 3 x to the 3/2 minus 1. All right, if I was to plug this into the calculator, it turns out to be a curve that looks something like this. And goes to 1. Or essentially, what is the length of the curve? That's the problem. So, all you have to do is, first of all, do what? Take the derivative. So what is f prime? It's the derivative of this function, which would be 4 square root of 2 over 3 times 3/2 x to the 1/2, which becomes, 2 root 2. 3's cancel. 2 goes into 4 twice, so 2 root 2 x to the 1/2 square root of x. All right? And so now, what's the length? The length is the integral that goes from 0 to 1, square root of 1 plus the derivative squared. This thing squared, so we're looking at 2 root 2 x to the 1/2 squared. How do we know it's root 1? Because I stated that. All right. And let's simplify that. 1 plus 2 root 2 is 8. Yeah, because 2 squared is 4, square root of 2 squared is 2. So that would be 8 x dx. Now, if it did not say analytically, you could just plug in your calculator. But, so we don't forget, let's practice, because this one isn't too bad. How would you integrate that? I'm sorry, Mike. How would you integrate that?
1 plus root of power.
Change the square root to 1/2 power. But then we still have to do what? Not by parts, by substitution. Remember, whenever you have a messy thing, if substitution will make it less messy, that's the route to go. So there's u. What's a du? 8 dx. That's perfect. 1/8 du will replace the dx. And so now this becomes an integral of u to the 1/2 times 1/8 du. Now, one thing you need to note, and this will be wrong in the AP test, is you mustn't put a 1 or a 0 here. Why? Because now we're using u's, we're not using x's. So you have two alternatives. One, figure out what the u's would be, or just leave it alone and then back at the end, convert it back to x's. You with me? You know, if when x is 0, what's u? U is 1. When x is 1, u is going to be 9. So, if you do change it,